Hello students. Today we will learn about the different types of resistors. So we know that there are two types of resistors, fixed resistors and variable resistors. So first, today we will study the different types of fixed type resistors. Fixed type resistors, the resistance value is fixed. We cannot change or we cannot vary the resistance value. For example, suppose 100 ohm resistance, fixed resistance, having color brown, black, brown, we cannot change this resistance value. So it is called as a fixed resistor. Okay, so there are two types of resistors, fixed resistors and variable resistors. So today we will study different types of fixed resistors. So first type is a carbon composition type resistors. Okay, carbon composition type resistor. So in carbon composition type resistors, there are four color rings, and we can know, or we will learn, or we will know the value of the resistance by using color rings. By using or if we observe the color rings, we can find out the value of that resistance. Okay, so these carbon composition resistors are widely used in electronic circuits. These resistors are widely in large scale. These resistors are used on PCB, uh, or these resistors are used in large scale in electronic circuits. That these resistors are widely used in electronic circuits, and these carbon composition resistors are available from 1/8 watt to up to 2 watt. Up to 2 watt, these resistors are available. From 1/8 watt, 1/4 watt, 1/2 watt, then 1 watt or 2 watt. Okay, so these resistors are available from the power ratings from 1/8 watt to 1/8 watt to 2 watt. Okay, and these resistors are available from 1 ohm to uh, 20 mega ohm. Okay, 1 ohm to 20 mega ohm, these resistors are available, and their power ratings are from 1/8 watt to 2 watt. Okay, then the speciality of these resistors is its low cost and small in size, and its cost is low. Okay, these resistors are manufactured, these resistors are made or manufactured by mixing uh, granules of carbon with some binding material, and then this mixture is then molded in cylindrical form. This mixture is then molded in cylindrical form, and then tin copper wire leads are inserted in the two ends. At the two ends, two copper wires, tin copper wires are inserted in the two ends, and this whole structure is then sealed with some non-conductive material. This whole structure is then sealed with some non-conductive material. Now the cost of this carbon composition resistor depends upon its wattage. If high wattage resistance is there, then its cost is more than a low wattage resistor. So uh, high wattage resistors are costly. Okay, so this is about carbon composition resistors. Okay, so these carbon composition resistors are widely used in electronic circuits. These resistors are available from 1 ohm to 20 mega ohm. Then its power ratings are from 1/8 watt to 2 watt. Okay, and these carbon composition resistors uh, are fabricated, or these manufactured by mixing mixing granules of carbon with some binding material, and then this mixture is then molded. This mixture is then molded in cylindrical form, and two tin copper lids are then inserted in the two sides of this resistor, and this whole structure is then sealed with some non-conductive material. Okay, the cost of this resistor depends upon the wattage of resistor. If that is high wattage resistor is more costly than a low wattage resistor. Okay, so this is about carbon composition type resistors. So on carbon composition type resistor, there are 4 color rings, and by color code method we can find out the value of this value of that resistance. Okay, now second type is carbon film type resistor. Okay, carbon film type resistor. So this is another variety of carbon resistor. This is second type of resistor, or this is another variety of carbon resistor. So in which in carbon film resistor, thin film of carbon, thin film of carbon is deposited on insulating material like ceramic rod. Okay, like ceramic rod, thin film of carbon or carbon film is deposited on ceramic rod. Thin film of carbon, it is deposited on some insulating material like ceramic rod. Okay, now during the deposition of the film, the wire the during this deposition of film, the value of the resistance is adjusted. The value of the resistance is adjusted by uh, its resistance value can be adjusted with the length and width of the film. Okay, so the resistance value depends upon the length and width of the film. So this resistance value is adjusted its resistance value is adjusted by length and width of the film. Okay, then side caps are fixed or fitted at both ends of the resistor. The tin copper wire is welded to the end caps, and the typical range of these resistors is from 10 ohm to 10 mega ohm. These resistors are available. Carbon film resistors are available from 10 ohm to 10 mega ohm. Okay, and the uh, power rating of these resistors are up to 2 watt. Up to 2 watt, these resistors are available, and their tolerance is from plus or minus 1% to plus or minus 5%. Tolerance of these carbon film resistors uh, tolerance is from plus or minus 1% to plus or minus 5%. So these resistors are called as precision type resistors. These resistors are called as precision type resistors. Okay, and another speciality of these resistors is its low cost and low noise. Its cost is low and low noise than carbon composition type. Okay, so its range is resistance range is from 10 ohm to 10 mega ohm. Then power rating is up to 2 watt, and its cost is low, that is low cost and low noise. So these resistors are called as precision type resistors. Okay, now next type we have wire wound resistor, wire wound fixed type resistors. Okay, now, see, this is the sketch or figure of wire wound resistor. So here there is one ceramic rod and one wire, resistive wire. For example, nichrome wire or manganese, nichrome or manganese, such type of wire. It is wound on this ceramic rod in wire wound resistor. So wire wound resistor, it is used for high current circuits. Okay, when high current is to be controlled, then wire wound type resistors are used because its power rating is more than this carbon composition or carbon film resistors. Its power rating is large. Therefore, when high current is to be controlled, then these resistors are used. Wire wound resistors are used, and wire wound resistor is manufactured. These resistors are manufactured by winding the length of a special resistive wire like nichrome or manganese around an insulating core of ceramic. Okay, manganese or uh, nichrome wire is wound on ceramic rod, that is by winding or by wrapping means gundalne. So by wrapping or winding a special type of resistive wire like nichrome or manganese, this wire is wound on the ceramic rod. Okay, and the end of the wires are then attached to the metal contacts. Okay, metal contacts which is inserted in the core. After wire is wound, the whole structure is then coated with enamel. This whole structure is then coated with enamel and containing glass powder. It is this winding is then coated with powdered glass. Okay, it is called as enamel coating, and then it is heated to produce coating. This this coating is then heated, and this coating is then called as vitreous enamel coating. This coating is then called as this is known as vitreous enamel coating. So it is required, this vitreous enamel coating, it is required to protect the wire. It is required to protect the resistive wire, or to protect this resistance. This vitreous enamel coating is necessary, and to dissipate the heat. So typical values of these wire wound resistors are typical values are from fraction of ohms to up to 100 kilo ohms. Up to 100 kilo ohms, these resistors are available. Then its power rating is from 5 watt to 200 watt. This the power rating of wire wound resistors is from 5 watt to 200 watt. The drawback of this resistor is its big size. It is the drawback of this resistor because its size is big. So these resistors are big, so this is the drawback, and its higher values are not possible. Resistance values, high resistance are not possible, and specialty is its big in size and more power handling capacity. It is the specialty, more power handling capacity, and range, it is resistance range is from fraction of ohms to up to 100 kilo ohms, 100 kilo ohms, and power rating from 5 watt to 200 watt. Its power rating from 5 watt to 200 watt. Okay, so this is about wire wound resistors. Now we will study another type of resistor, that is variable resistors. Variable resistors. So variable resistors, these variable resistors are also, there are two types of variable resistors, that is a carbon type variable resistor and wire wound type variable resistor. So these variable resistors are also called as potentiometer. Variable resistors are also called as potentiometer. So small variable resistors are called as potentiometers, whereas big variable resistors, this big variable resistor, it is called as a rheostat. This is a rheostat, and this is a carbon potentiometer, that is, it is a variable resistance. Its resistance varies when shaft is rotated. When this shaft is rotated, its resistance can be changed or varied when one fixed terminal is connected to variable terminals. So here this carbon potentiometer has three terminals, 1, 2, 3, 1, 2, 3. So between terminals 1 and 3, we get the fixed value of that resistance. For example, if this potentiometer is of 100 kilo ohm, then between these two fixed points, that is terminal 1 and terminal 3, we get 100 kilo ohm resistance. But when the middle terminal is connected to any one of the fixed terminal and then shaft is moved, then we can see the resistance variable. Okay, or no, we get a variable resistance when shaft is moved. Okay, when shaft is moved, then we get variable resistance. That is, we can change this resistance from 1 ohm to 100 kilo ohm. Okay, so this is a carbon potentiometer. It is a variable resistance. Okay. Now, these resistors are used in many electronic circuits. Wire wound carbon potentiometer, these variable resistors or potentiometers are widely used in many electronic circuits and in audio equipments as a volume control. In audio equipments as a volume control, and in TV receivers as a brightness control or contrast control. Okay, in TV sets. So according to the material used, these potentiometers or variable resistors are of two types: carbon potentiometer and wire wound potentiometer. Okay, then uh, now we will study the construction of carbon potentiometer. Construction of carbon type potentiometer. So in this type, movable metal pointer is known as wiper. This is a movable point. This So in this potentiometer there is a movable point. It is called as a pointer, and this movable pointer it is called as wiper. It is called as wiper, which moves on a circular ring. This wiper moves on this circular ring, and this circular ring is a carbon resistive track. It is a circular carbon resistive track. That is, this ring is of carbon. This ring is made from carbon. Carbon material is deposited on this circular ring. Okay. Then this wiper is attached to the shaft. This wiper is attached to the shaft, and it may be metal or plastic shaft. This shaft will be either it is made from metal or from plastic. This shaft. Okay. Then resistive carbon material is deposited on this bakelite piece. This is a bakelite piece, and on this bakelite piece, some resistive material it is deposited. That is carbon. Carbon is deposited on this bakelite, and resistive carbon material it is deposited on bakelite piece. Then variable resistors have three terminals. 1 and 3 are fixed terminals, and second middle terminal, that is second terminal, it is a variable terminal. Then between 1 and 3 terminals we get the full resistance of the potentiometer, and but when terminal 1 and 2 or terminal 2 and 3 are shorted or connected together, then we will get variable resistance when shaft is rotated. These variable resistors are available in two types. These variable resistors or potentiometer, there are again two types: linear type potentiometer and log type potentiometer. There are two types: linear and log type. So in linear type potentiometer, resistance varies in a linear rate. The resistance varies in linear rate. That is, if you rotate the shaft, suppose for 10 degrees Celsius, for 10 degree. Suppose this shaft is rotated for 10 degree, then it gives 100 ohm resistor. Then at 20 degree, it gives 200 ohm resistance, like this. But in a non-linear type potentiometer, also called as log type potentiometer, its resistance varies in a log scale. Its resistance varies in a log scale. That is, at 10 degree, we get 10 ohm resistor. Then at 20 degree, we get 100 ohm resistor. At 30 degree, we get 1000 ohm resistor. Okay. So this is about variable resistor or potentiometer. Then there is also one another type, small potentiometer. It is called as a preset, small resistor, small variable resistor. It is called as a preset. So in preset, variation of resistance, it is done with the help of screwdriver. With the help of screwdriver, we can change the value of the resistance. Okay. Now carbon type potentiometers are available from 1 kilo ohm to 5 mega ohms. These carbon potentiometers are available from 1 kilo ohm to 5 mega ohms, and their power ratings is up to 2 watt, from 1 half watt to 2 watt, and one power on off switch is also used. On off switch is also used with this potentiometer. Oh, okay. So such type of potentiometer having on-off switch, it is called as a volume control. It is called as volume control. So in volume control, there is a in backside there is one on-off switch. That means we can switch on and switch off the circuit. There is a switching facility in this type of potentiometer. Okay. Now second type, wire wound potentiometer. So this is a wire wound type potentiometer or wire wound type variable resistance. So the most common example of this type of is a rheostat. This is rheostat. It is a wire wound potentiometer or wire wound type variable resistance, because here nichrome wire, it is wound on ceramic rod. On ceramic rod, nichrome wire is wound. So this rheostat, it is called as a wire wound type potentiometer. Okay. In this type, wire is wound on an open ring or hollow ceramic rod, hollow or open ring type ceramic rod. Wire is wound, and this wire is called as nichrome wire. It is a nichrome type wire, or it is a nichrome wire, or this is a this wire, this type of wire, it is a nichrome wire. So nichrome wire is wound on ceramic rod. Then this is it, this winding, it is covered with, this winding, it is covered with vitreous enamel. This wire, it is covered with vitreous enamel. The speciality of such type is its high power handling capacity and very small and accurate change in resistance. Okay, accurate change in resistance and uh, accurate resistance. Then by sliding the contact, the variation of resistance is uh, achieved. Variation of resistance is achieved by sliding the contact. Here this is a slider. So when we move this slider, then resistance value can be changed. Okay. Then specialty, its cost is very high cost, but more power handling capacity and large size. So this is the specialty, high power handling capacity or more power handling capacity, then high cost and large in size. Then its resistance range is from 100 ohm to 1 mega ohm. So these rheostats are available from 100 ohm to 1 mega ohm, and power rating from 2 watt to 100 watt. These rheostats are available with power rating 2 watt to 100 watt. Now there are some other resistors also. So these special type of resistors, for example, thermistors, then LDR or light dependent resistor. Okay, so these are special type of resistors. So because of the large development in semiconductors, special type of resistors are made. Special type of resistors are manufactured due to the large development in semiconductor technology. Okay, so first is a thermistor. So this is a symbol of thermistor. So thermistor, its resistance varies with temperature. Its resistance varies with temperature. So there are two types of thermistors, NTC, NTC thermistor and PTC type thermistor. So in NTC type thermistor, NTC means negative temperature coefficient of resistance. Negative temperature coefficient of resistance. So this is called as NTC thermistor, and second type is PTC, that is positive temperature coefficient of resistance. So in NTC type thermistor, its resistance decreases with increase in temperature. The resistance of this type thermistor, that is resistance of NTC type thermistor, resistance of NTC type thermistor decreases with increase in temperature. When temperature increases, its resistance decreases. And in PTC type, the resistance increases with increase in temperature. So this is called as PTC type thermistor. Okay, so the a thermistor, it is a semiconductor device. Thermistor is a semiconductor device whose resistance varies with temperature. Its resistance varies with temperature, but this change in resistance is non-linear. Okay, there are two types, NTC and PTC, and these thermistors are used in many applications, like in temperature controller circuits or in for measurement of temperature. So in temperature control circuits or in heater control, these thermistors are used. Okay. The next type is LDR. LDR. LDR means light dependent resistor. LDR. This is the symbol of LDR. LDR is also called as photoconductive cell. LDR is also called as photoconductive cell or light dependent resistor. LDR means light dependent resistance. Means its resistance depends upon intensity of light. Its resistance depends upon intensity of light. Means when intensity of light is more, its resistance will be low. Means the resistance value decreases. Resistance of LDR decreases when light intensity increases. When light is incident on LDR and if its intensity is large, then its resistance decreases. But in dark condition, the resistance of LDR increases. In dark condition, its resistance increases. So this is called as light dependent resistor. Okay. So this LDR is a photosensitive device. It is a photosensitive device and whose resistance decreases with increase in light intensity. Its resistance decreases with increase in light intensity. Then cadmium sulfide type material is used in LDR. In LDR, cadmium sulfide type material is used. In LDR, cadmium sulfide is used as a photosensitive material. Okay, cadmium sulfide material is used for this purpose. Then its dark resistance is about 100 kilo ohm. Its dark resistance is about 100 kilo ohm, and it decreases with light intensity. Light intensity. Okay, so LDR, it is widely used in many applications like automatic street light control or in burglar alarm circuits. This LDR is used as a sensor. Okay, light dependent resistor. Then next type is a varistor or voltage dependent resistor. Varistor. Okay, so it is also a non-linear type resistor, and it in this resistor uh, it is made from it is made variable. This VDR, its resistance is made variable with voltage. Its resistance is made variable with voltage, means its resistance depends upon uh, voltage applied across this VDR. Voltage applied across it. Voltage applied across it. Its resistance depends upon voltage. So it is known as voltage dependent resistor, VDR. Okay. So this is also a non-linear type resistance, and it is this resistance is made variable with voltage. So it is also called as voltage dependent resistor. So there are two types of VDR. There are two types of VDR, or there are two types of voltage dependent resistors. One is a silicon carbide type VDR, and second is a metal oxide VDR, silicon carbide VDR and metal oxide VDR. So these are the two types of VDR, and these varistors or VDR, it is also called as varistor. So these varistors are used in many industrial applications and in TV circuits also to surge suppression. Or to surge suppression, this VDR is used in TV sets. Okay. So this is about varistor, or so these are the different types of resistors. These are the different types of resistors. So we will stop here.